Hello and welcome to this video about Chapter 7 Study Guide. My intent is to work an example problem or two through each section so that as you have yours out in front of you as you watch this video, you can either learn how to do it or check your answers in the work. All answers have been provided on the very last page of the study guide. So as we can begin here, the very first thing is we need to state if the polygons are similar. How you do that is similarity requires two items. One, it requires congruent angles. Number two, it requires proportion in the sense of the proportional sides. So we're going to create a proportion and we're going to cross multiply. If you examine down here each of these questions, you need to look at for congruent angles. There, that's better. Congruent angles. And so like in number one, that angle is 50. In the same corner, this angle is 50. So they're congruent. Number two, the bottom left corner here is 65. I don't have anything in this one's bottom left corner. So automatically you might think since this is 65 and that one is 115, there is an error in that they cannot be similar because of number one up here. But in fact, if you add these two numbers together and they equal 180, the properties of parallelograms from chapter 6 still hold. And since 115 and 65 together are 180, that means this also down here is 65. So at least angle-wise, they're congruent. As far as setting up a proportion, what you must do is pick the sides that match. So 12 and 16 would go together. This 18 and this 24. And you're going to write a proportion like so. And what you're going to do is multiply by cross multiplication to see whether the number of the product of 12 times 24 is the same as 16 times 18. And it so happens that both products or both multiplication problems answers gives you the number 288. So with similar in your mind here, congruent angles, proportional sides, we have congruent angles, we have proportional sides, so that yes, they are similar. And this is the similar symbol for similarity, I mean. And you would continue that through this section. Moving on. The next section, it says something about finding the scale factor, and it references smaller to larger. All that means is that you must pick from one shape. So here I'm at the number 7. I want to pick this side of this shape, which is the left side, with the shape here's left side. Those two, you'll write them down as a fraction, and then you would want to reduce this, and if possible, use your calculator. And this would reduce down to 4 over 5. So what that means is that for 4 units of length in this shape, it would work up and correspond with 5 units of length over here. Flipping the page, the next section you must do is that the polygons in each pair are similar. And so you're asked to find the missing side, and that is given by a question mark. Now then, what we're going to do is the same as what we have said before, that similar means the sides are proportional, or that they scale up by a single numerical value. In order to find the missing side given by the question mark you see underlined, we are going to create a proportion, which would look something like this. And if you chose to, you could put an X there where the question mark is. And simply, you must do what you were taught from long ago. To find the answer to a proportion is to cross multiply, divide, and you will get your answer. So as you wait for me, get your calculator, and do this yourself. And as I am typing this in, I see that my missing side is 35. There you have it. Okay, that would be what you'd continue on with all of them. And you might need to rearrange or reorient. If you look at number 15 here, this shape is tilted to the right that way compared to the other one over here. And so in essence, what you need to do is flip it around. And if you notice that this angle right here is the kind of the telltale sign of what the shape looks like, match that up with this one over here. So that would mean that 4 and the question mark would go together. And 8 here and 40 would go together. Just a way to align each of them so you know who goes with what. Okay, moving on to the next one. And now it says here at the top of the page, solve for x. All of that means is that we're going to now have algebra involved, more involvement in our proportions, but we are still going to write proportions, such as 2x minus 8 over 12 is equal to 8 over 6. We still cross multiply, but what happens is we're going to have an expression get multiplied by a number, and we now have to use the distributive property. So I'm going to continue this over here. We will distribute and get 12x minus 48 equals 96. And we'll continue solving and go on from there. And get 144. And x is equal to 12. Okay, so the polygons in each pair are similar. And that's why it allows us to do all this. And you'll repeat that all the way through. And then down at the bottom, state if the triangles in each pair are similar. If so, state how you know they're similar and complete the similarity statement. Here, we're still looking for congruent angles, so we have some congruent angles there and there. We're going to check the sides are proportional, and it's kind of obvious sometimes, but you could just say, I'm going to do 6 over 6 and 27 over 27. And if you cross multiply, you're going to end up getting the same value. And that ends up being 162 and 162, and so that checks out. So we have these two triangles are similar, and this similarity statement here is just simply finishing it. It says B, C, D. So up here we're going to start with angle, I believe that was E. Let me erase that so we can see that. Yes, angle E. So we would say triangle E, F, G, and that's the similarity statement. If so, state how you know. Well, how do we know that they're similar? Well, that's going to be some of that other stuff that we learned about, where there's things called angle-angle similarity and side-angle-side similarity. And the last one was side-side-side similarity. Okay, now think about that. We'll go back to those things. What do we have here? Well, we have a version of this called side-angle-side. So there is your proof in the work here. There is your similarity statement and the reason, all in one. One thing you want to look for is like on number 24, you have vertical angles there. And very well maybe side angle side again. Sides must be proportional. Okay, moving on. You're going to be doing that some more on this page. Number 27, finding the missing lengths in the triangle. The triangles in each pair are similar. It's the same thing as when we had polygons. You're going to write a proportion. And so you would say 20 over 10 is equal to 30 over question mark. Cross multiply and divide. And there you will have your answer. And you get that with calculator. And then moving on, we have solve for x with triangles. It's very much the same as what you did with polygons. The reason they give you this angle here here is so that you can align your triangles and match up the corresponding or matching sides. We're still having proportions and cross multiply. Distribute. Whoa, sorry about that. Don't know what that was. And see what we get here. So x is equal to 3. Do that. Continuing, we're still using that same idea. These are proportions in triangles. So ones like number 3, the way the drawing is, just realize that 12 represents the length from here to there, or that whole side. So if that whole thing is 12, this little piece right here would be like 12 minus x. Take that little piece off of 12 and you have it. Oh, excuse me. Pointed the wrong one. Pointed the wrong one here. 12 minus x would be right there. This would be x. Got a little ahead of myself. Sorry about that. And then here's some ones where they ask you to solve for x. Well, the proportions are created by these parallel lines right here. Those two parallel lines create this are the things you're looking for. Now, don't confuse that with congruency. I just don't have any other way to show you that since you can't see it. Okay, so what we're going to do is we're going to set up another proportion here, and the proportionality of this is going to be that we're going to look at the pieces that are created by, or the segments that are created by the parallel lines. So you could do something like 4 over 8 is equal to negative 5 plus 2x all over 14, and we still are going to do some cross multiplying here. I'll check this. I think that's 96. Nope, 56. See, that's why it's handy to have a calculator right by you. And then, if you don't mind, I want to do this, speed it up a little bit. Just a little jazz of a way to do algebra. And 2x is going to equal 12, so we have x is equal to 6, and so on. Just pay attention that sometimes you need to take back something. Like if this part right here, number 43, is 4, and the whole thing is 20, that means this part right here has got to be 16. That should make sense. There may be some of them that are going to be more involved than that. In the same way on like the next page, number 45, that's got to be 8. Why? The whole thing from here to here is 28. This little piece is 20. 28 minus 20 is 8. So on and so forth. And you're still going to set up, basically, you can call this x and do x over 35 is equal to 8 over 20. Cross multiply, divide, you have your answer. And here again, calculator is your best friend. So 35 times 8 divided by 20, x equals 14. And rounding out the fast finish here of some more solving for x, you're going to still have this where you're going to have these segments. So you're going to have things like 8 over 12 is equal to 2x minus 10 all over 15, and cross multiply and solve just like that. And I'll let you finish that one. And really, the worst one that I've seen would be the next one, number 50, in that if this whole thing is represented as 2x plus 10, just like this one's 18, I want to find this little piece. Well, that little piece is found by taking the total minus this part, and that would be 12 for this one. The total up here is 2x plus 10, and if I subtract away the little piece, that's going to give me 2x minus 6, and that's how that much is. That's how big that much is. I forgot my word big. Sorry about that. Anyways, how you do that is in a proportion. Yet one more time, and you could set it up just about any way you want. You can go and do 12 over 6 is equal to 16 over 2x minus 6, and go ahead and solve it, and that should be your answer. And see if there's anything else. Well, moving on. And then the last one's where we're getting to, this is the idea that an angle bisector, here's the angle bisector, can create proportional pieces. If whole thing is x, this is going to be x minus 6. And you could do a setup of something like 8 over x minus 6 is equal to 12 over 6, and that should give you the right answer. And I don't have the right answers in front of me. You do. I hope you're checking them. That should give you 48. And then before, x should equal 10 here. Number 53, let's go and check. Number 53. 53, x equals 10. Yay, I got it. And so on and so forth. The last few are ones that look like this. As you've done before, just take and get your piece that you need. If this whole thing is 16, that means that part's got to be 10, and so on, and set up a proportion and solve. I hope this video has been a help to you. If you need more assistance, you know what to do. Thank you for your time. Thanks for watching.